Okay, we are ready to roll. Eric, for the opportunity to speak today, and thanks everyone for tuning in. We're glad to have the opportunity to share what we believe is some important information on integrated water management. At the outset, I think it's fair to say that this is not a simple or easy topic, so we want to mislead anyone by thinking that we can boil this down to a couple of nice sound bites. That's not quite the way it is. Most of you are familiar with integrated water management. It's almost become something of a catchphrase, but the implementation of it has not been achieved in the sense of true integration. So take this opportunity to present a perspective through which stakeholders can realize many more benefits through true integrated water management. So today we'll be talking want to give a better idea of what do we mean when we talk about integrated water management as a concept, and how does it compare to the current thinking and approaches in managing water resources and water issues. And components of integration. How do you go about implementing integrated water management? And down and for a case study, and we'll look at integrated water management from the water quality element or the water quality segment of that. So look at the water environment. We have multiple elements: water quality, water resources, habitat, etc. Case study will focus down on this one element that is needed to integrate the entire quality environment. So title slide, we want to introduce a couple of key concepts and terminology that will carry over to the rest of the discussion today. The first is that water is found on many different geographic scales, and be a golf course drainage, a river delta, or a watershed. And water is part of an integrated ecosystem. So that the water in the ecosystems exist in an integrated state, their management is very fragmented because of the large number of stakeholders that exist in a particular area. Budgets that are allocated by the program are silo to implement those programs. And the interest of a particular stakeholder can vary from a backyard landscape to a groundwater basin or a watershed. What we're going to be discussing today, it's important to remember that any of these scales can be regarded as a water environment and part of a larger ecosystem. Integrated management as a concept. I think it's worth just kind of stating aloud here this first bullet, that integrated management views the water environment as an integrated interdependent system. Water environments and the ecosystems are extremely complex, so we need a framework of how to manage them. The time I have today, I don't think we'll be able to get to an entire answer, but we'll provide a basis by discussing these three bullet points here. So that is to bring data from the individual subsystems or the elements into a unified platform so we can interplay the different data sets for whatever purpose we want, whether that be visualizing the data, performing analysis on the data, modeling or reporting with the data. For example, integrated monitoring, you'd be looking at data sets from multiple programs such as dry weather monitoring, maybe coastal storm drains, maybe beach monitoring. You have sharing of the data, and if data doesn't just by itself, it comes from people and organizations. Without sharing and collaboration, there cannot be integration. And what so far is people are focused mostly on the collaboration and processes like IRWIM. So for those of us in California, we're probably familiar with that. That's the Integrated Regional Water Management. These processes do provide some sharing of information, but not as much sharing as we would like. And last point, which is important as well, integration is not data management or GIS. Integration represents a process, not a particular technology. Okay, how did we get here, and why are we talking about integrated water management? For years, we think integration has been coming down to us from a policy and regulatory perspective. We have seen integration in policy and planning and in regulatory drivers. Regulators, which typically a permit associated with them, are focused on the outcomes. So the permittees need to look at the larger water environment where they implement a permit to produce results. We also see integration in reports that are required by these permits, and this includes reports at both the stakeholder and the watershed level. I believe that the intent here is to achieve some level of integration. So looking forward, we believe that integration is here to stay, and it's primarily because of the benefits that it can yield. So this is a short list of some general benefits. Now there's some specific benefits that depend upon the particular application, but at the fundamental level, what integration can achieve is more efficient and sustainable outcomes. Sustainability is a very important part of that, because it means you have to look at your resource to be managed as a system. You can't optimize one element of it at cost or the neglect of the others. So some of the benefits that we see listed here are smarter ways of solving local problems, and this will become, I think, if not already, very important, because budgets have already constricted considerably in the last few years. Regulations get more complex. Stakeholders will need to start thinking in terms of integrated strategies to achieve programs. So we contrast the integrated water management approach with a conventional approach, the conventional approach being what we think has gone on for the most part up to date. So the water environment has been managed in a segmented or fragmented way. Different programs or projects are being managed by and large on a standalone basis, and we see that here in this schematic where we have the customer organization and then different programs separated out below that. And we also see this in terms of the data management. Not only are the programs separated out, but often you see the data management as a separate box or silo. And so this type of approach is in the opposite or wrong direction from integration. So what's the right approach? Well, before we get to that, we need to look at the system to be managed, and in this case, it'll be the water environment. And the water environment consists of many elements. So these elements I'm referring to are in that top row of the different, and those are the different column headings there. We see water quality, land use, water resources, habitat. And again, it does not matter what scale we're looking at, because all the elements are interacting with each other. And you're picking one element to optimize at the exclusion of others. That is an unsustainable outcome, and what we are proposing is a better alternative. Okay, that background, let's try to explain what true integration should be. And this is a little complicated, but it is a complex issue, and we can't really dumb it down. So starting at the top here in the customer organization, there's an important point to be made, and that is that integration does not have to be at a very grand scale involving 30 or 40 entities coming together for endless meetings. Integration can be enabled and is recommended at an individual stakeholder level. So whether you're a regulatory agency like a regional board, a conservancy, wastewater agency, or stormwater, are dependent within one of these, if you deal with water issues over some geographic scale, you need to consider the integrated approach. If not for the external water environment, then for your internal data management, operation, and processes. I believe that if you think through the integrated process, most agencies would say 40 to 50% savings through integrating and automation of internal tasks in an integrated approach. So as far as the schematic here, what integration involves is all projects, looking at what's going on in all of the projects, and going through the data and process integration for each one, instead of putting them into those separate silos, and integrate all the elements together. So here's your elements on the side of the screen. These elements are in sharing along this common vertical bar here. Different projects of the customer organization all have access to the same vertical bar, which represents the data. So, for example, if you were going to integrate the water quality element, then your program might be stormwater, dry weather monitoring, TMDL implementation, spill reporting. And if you need to optimize each one of these because you're still managing those projects at the individual level, and the operations, budgets, and reports are handled at that individual project level. And most program managers are able to achieve this level of program optimization. The hurdle seems to be bringing together all those programs into a unified approach for that water quality element. And when you do this, then you can reduce the time and effort related to those internal processes. And the outcome of the processes, the reports and the assessments, is the focus rather than the process itself. It's for a permittee to make the process as effective and efficient as possible. I believe the integrated water management is one approach to do that. Okay, so this matrix, we're showing the stakeholders and the relevant elements in the water environment for each. So the stakeholders down the left-hand side there, again, our water elements are in that top row, columns to the right of the stakeholders. We can see that elements are affected by many stakeholders, or I should say stakeholders have different interests in different elements, and others not as many. And there are some stakeholders who have an interest in several elements, and some that have interest in fewer. Points here, no one in the water environment can escape the fact that the ecosystem is integrated. And so one aspect of your project or role may be affecting other elements in the water environment. Now, if a person wants to realize this and benefit from it, that might be another matter. Second point is almost everyone or stakeholder can benefit by adopting an integrated approach if you believe integration has benefits. We'll talk about integration for your own department or program. What are the key functionalities required to do that? So first and foremost, you have to aggregate the data. And whether your data is sitting in 10 servers or 10 databases, you have to have a unified access to the data for visualization and analysis, so you can mix and match data from a number of different sources in different ways to suit the needs of the day or whatever the particular user needs. And something to bring up here, this is a more complicated task than just putting all the data into a central filing cabinet or central location. We have seen going on. We don't that as integration. Integration is the ability to mix and match the data in different ways and use tools on the data. And by tools, I'm talking about searching, sorting, custom analysis, statistics, modeling, and reporting. And because data by itself doesn't mean a whole lot, it has to be the ability to use the data. Data does not come its own space in the outer world. It comes from people and organizations. So in order to help people make better decisions and use the data to improve the data collection process, you have to have people involved. So our thesis, our point of view is that while it can be integrated, you can achieve integrated resource management unless you enable the sharing of data and collect between departments. And when we say integration and collaboration. We're not necessarily saying that you have to have 20 people sitting together in meetings that go on and on. The integration at the individual stakeholder level can be a department, can be a program within a department. That integration at that individual stakeholder level does not happen. It's doubtful that it can be achieved at the bigger scale. Okay. We want to zoom out, or zoom in, so we're talking broadly about integrated water management and integration, and now we want to zoom in our focus. What are the functions required for integrated water management at water quality element? So water quality presents one of the many elements for the water environment. The stakeholder scale can be focused to a department level. The integration of the water environment starts by focusing on the elements. So water quality, we can start thinking in terms of individual functions like MS4 monitoring, stormwater monitoring, which has several programs, dry weather, illicit discharge and detection elimination, wet weather outfall monitoring, coastal storm drains, etc. Program can benefit from better management of data and processes and removing redundancies. So examples of how integration can be approached for the water quality element. We are generally familiar with it because we know it can be accomplished. But when it comes to the how, there are not a whole lot of tools out there. But with the integration of the water environment elements can be done, and we are doing it as a company for several situations. And the combination you can accomplish in terms of metrics, monitoring, data admin, those can, again, they can happen down at the department or program level, and you don't have 30 people working under the guidance of a consultant to achieve this. Key components for the water quality slice or element of integrated water management. We'll talk this here. Well, you can refer to these as the toolbox. So you recognize a lot of these if you've viewed any of Eric's past webinars. Many of these have been presented in SAS webinars, so it's nothing new. It's just a matter of getting the different components together and having the tools to use the data. Okay, and this diagram is a feedback loop, and it's important that we mention a feedback loop because of the fact that the elements in the water environment are interdependent, and no meta-analysis has been done or how finally you look at the data and taken to improve one element will invariably affect another element. So it's clear that the stakeholders, public and the agencies that are implementing these programs here, it's cool that they be involved in a feedback loop so they can see where there are positive and negative impacts of their programs. And of course, if you're looking at just maybe a very small slice of an element, like water quality analytes, then maybe this theory does not apply. The whole point has been that the discussion so far, if you're looking at 2 water quality analytes, that's not enough, and you need to look at a larger picture of elements that are relevant to your organization in terms of lowering costs and improving outcomes. As the importance of the feedback loop is most apparent when looking at regulatory permits. For example, the stormwater permits. We've seen that these permits are very procedural in that they have very prescriptive requirements, and there's just a script that has been written, and this is the open loop that as long as you follow the script of the permit, your work's done. But this type of management system is not efficient. And I think a better approach would be some type of a feedback mechanism. Instead of a regulation creating a checkbox to be marked, the stakeholders or the permittees have an incentive to change their programs based upon the feedback they get so that the quality of their water resource is maintained. Okay. So probably most of you have already been thinking about this in terms of the application, but there are areas of application for integrated water management where we most working in one or more of these. And again, the line is that the integrated water management approach would allow these programs to be performed more efficiently and effectively. Okay. Probably worthwhile to also mention some of the challenges that come along with integrated water management. Certain inertia or dependency that comes along with the status quo, and there's certain processes that are difficult to change. It's worth pointing out that there are beneficiaries of the current inefficiencies as we see them. There's the data availability and access, and perhaps as important as anything else is the lack of the right cost-effective tools. A lot of public funds directed toward the components of integration in California, but I think the cost-benefit of those efforts could be debated, but I'm not trying to open up that debate here. I'm just pointing it out. Okay, so just to a quick wrap, what integrated water management is not. It's not data management, it's not GIS, and it's not the synergistic collaborative projects. Okay, so I want to digest that. What I'd like to do now is shift gears and present some nice visuals. And these visuals will be examples of the water quality components that we listed in the solutions toolbox. So look at this slide. This slide presents an online platform where the scale Watershed is offered on the left-hand side of the menu, and the right-hand side of the menu the different layers or folders of water quality data. So they include, depending on the application, it's water quality. These may include land use, soils, vegetation, stream flow, water monitoring, bioascent, facilities information, etc. So slides will be visuals, and there's probably not a whole lot to say. Table of stream gauge discharge. This shows a location of rain gauges, and rather than show the raw data itself, I thought it would be useful to take a screenshot of a platform that shows the visualization of the gauges. And from this point, the user can go to a particular site and pull down the data for that location. So now we're looking at land use data. Now we're looking at the soil data runoff class of that data. Then again, and you know which stakeholder you are. Some aspects of this are more relevant, some are not. Data by monitoring program. A little bit about this one. So on the left-hand side of the screen here, we see these folders or layers that can be selected. In the map view here, we see the watershed boundary in green. We see main river course presented within the boundary. And then there's a polygon here that's surrounding two of our wet weather outfall stations and then two of our receiving water bacteria monitoring stations. So the importance of having the tool that allows you to integrate the data is having that fine resolution that allows you to drill down to that scale of specific interest for you. Again, another screenshot showing some different that can be presented. These would be the EIR, CEQA type documents that can provide some background and history for particular locations. Stream information such as channel cross sections. Now we want to show some examples of integrated water management, data sorting, and presentation. Again, more visuals. So this is going back to the water quality data, and what box that's over is in play of the map right now. This is a filter box. So depending again upon the stake's interest, instead of 1,000 records, they only want to see 300 records, and so this type of a filter allows somebody to filter by the program name, hydrologic subarea, date, analyte, result. Example of a data presentation is a time series graph for stream flow. Third column are tabular data. And then let's go through the rest of these pretty quick. We've got some group reports and bit tables, which are useful for looking at multiple analytes. As pivot tables, you can create the graphs that look at analytes for the same location, all displayed together. We've got ammonia, nitrogen, and fecal coliform in this one. Quality results themed by color. So this is useful in terms of having a very good assessment of your saline data to determine which of your results are exceeding their water quality objectives. And this is an interesting tool. This is a source statistical software package called R that allows the presentation of the data. These are called box charts, which are showing the range of values for different lights within different segments of a water body. You can see at the bottom of those charts, it's all lower, mainstream, and upper. So that's a tool, I think. Another presentation using statistical package called R is the indicator with another parameter. This is a dissolved metal plotted against hardness with a tense here representing the acute and chronic toxicity thresholds. These are one of our channel cross-section. The EIR documents. A neat tool. Neat is probably not the right word. Very informative tool. So in this platform that we're kind of profiling here, specific area of geographical interest with your specific data layers of interest, you can export that view to anybody you like as a KMZ file. If the recipient has Google Earth, they can open up the file, see the location, see the data, click on the links, go straight into the portal to access the data. Okay. So that's all. If Eric, you want to come back in and we can address questions.
Thanks, Clay. Presentation. We have one question that was sent via chat. For those of you that have questions, you can send those via chat or you can unmute and play your question. Clay, the information sent in via chat was the USGS in their 2007-2017 strategic plan. They describe completing a water census. How would that water census affect integrated water management?
Would water census affect integrated water management? Condition of a water body, is that what a census takes?
I have not read a USGS strategic plan for 2007-2017, so I cannot help you.
Okay, well, I'll just guess at it, not having read it myself either. If it's source, and it's useful in terms to a particular stakeholder in making a decision, then it becomes a value. You know, again, it's is upon the stakeholder and what's relevant to them. Yeah. Hey, Eric, what we'll do here, we're going to put Joe in on speakerphone so we can tag team the answers if that's all right.
Oh, that's fine.
Yeah, hi, can you hear me?
Hi, Joe.
Yeah, hi. So the question I heard was that there is a USGS census of the water bodies in the U.S., how that can be used. In most simplest sense, that provides an additional source of data which individual stakeholders don't have to go collect. It's available off-site, and I think USGS, of all public sites we have seen, it's most fantastic. It's excellently designed, very easy to access data, and now whether the data is good or bad, I do not know, but it's an exercise. And so if people are doing certain water quality programs within their own jurisdiction, if there are monitoring sites, that data can be just brought in to further, as Clay was saying, integrated with the local collection of the data. So you can get data from multiple sources in an ideal sense of integration. Remember, one of the points mentioned was data can reside in 10 servers. So it can be anywhere. But as long as you can bring them all together to solve a local problem, I think it's beneficial.
Oh, thank you. Any other questions for our presenter?
This is Ken. I did send one by chat to Clay. I don't know if he got it.
Hi, thanks, Ken. Question is to regional tendency and implementation of IRWIM in California. Observation comes from what appears to be tendency along Central Coast to regard integrated water management as a province of resource managers, source waters, exclude wastewater and stormwater resource managers. How to be overcome? I did a couple of the IRWIM meetings here in San Diego. We have stormwater personnel at those meetings. We also have the water source managers at those meetings. So I'm not that I could say I notice it as much. Maybe Joe has a perspective on that.
Yeah, there's a couple of ways you can kind of look at the problem. That it's really focused around water resources. Pardon me? Yeah, you say it's focused primarily around water resources. It's probably a local issue about who's driving the process. That's something that you're in the best position to understand. But in terms of how do you go about resolving it, there are two kind of fundamental approaches that I think can work. One is, of course, the regulatory driver. Okay, that depends region by region. That's a heavy stick, and again, depends on the local situation. But so the regulations can be designed in a way which forces the stakeholders to start looking at things in an integrated way, which I think is happening in the San Diego area and some other regions. The other way is the incentives. If everybody is going to benefit by integration, I think there has to be a natural tendency for everybody to work together. Now the question is, how do you demonstrate the benefits? That's, again, so being so far away from the problem, I cannot answer that. But if there is a way you can demonstrate that by integrating these various domains of the water environment, everybody is going to benefit, that in times of tight budgets, I think people should be incentivized to approach it in that way.
The point to bring in, Joe, is if there's a process in place that's excluding the wastewater, the stormwater resource managers, then this example of the question, the IRWIM-focused solutions that are focusing on the source waters, you might want to see it 2, 3, 5 years down the line as impacts those other elements. The water quality measure as a result of focusing on the source.
The other way around.
Other way around too. Yep. Did I answer the question?
You did significantly. I just wanted to say that I appreciate the quality of the presentation and that question was informed by comparing notes other managers along the Central Coast. It appears that for some reason it's looked upon in my own jurisdiction. I noticed even the guy managing rivers for the city for hydrological purposes does a seat at the table at the IRWM meetings. But it's not peculiar to my city. It seems common on the Central Coast. But thank you for the effort. I appreciate it.
Issue, which it's an organizational issue.
Yeah.
Okay, thanks.
Take additional questions.